The Air Force chief scientist said F-35 pilots will be able to control a small group of drones flying nearby from the aircraft cockpit in the air, performing sensing, reconnaissance and targeting functions. At the moment, the flight path, sensor payload and weapons disposal of airborne drones such as Air Force Predators and Reapers are coordinated from ground control stations. In the future, drones may be fully operated from the cockpit of advanced fighter jets such as the Joint Strike Fighter or F-22, Air Force Chief Scientist Greg Zacharias told in an interview. The more autonomy and intelligence you can put on these vehicles, the more useful they will become, he said. This development could greatly enhance mission scope, flexibility and effectiveness by enabling a fighter jet to conduct a mission with more weapons, sensors, targeting technology and cargo, Zacharias explained. For instance, real-time video feeds from the electro-optical/infrared sensors on board an Air Force Predator, Reaper or Global Hawk drone could go directly into an F-35 cockpit, without needing to go to a ground control station. This could speed up targeting and tactical input from drones on reconnaissance missions in the vicinity of where a fighter pilot might want to attack. In fast-moving combat circumstances involving both air-to-air and air-to-ground threats, increased speed could make a large difference. It's almost inevitable people will be saying, "I want more missiles on board to get through defenses," or "I need some new electronic warfare countermeasures because I don't have the payload to carry a super big pod," he explained. A high-powered microwave may have some potential that will require a dedicated platform. The negative side is you have to watch out that you don't overload the pilot, Zacharias added. In addition, drones could be programmed to fly into heavily defended or high-risk areas ahead of manned fighter jets in order to assess enemy air defenses and reduce risk to pilots. Decision aids will be in cockpit or on the ground and more platform-oriented autonomous systems. A wingman, for instance, might be carrying extra weapons, conduct ISR tasks or help to defend an area, he said. Advances in computer power, processing speed and areas referred to as artificial intelligence are rapidly changing the scope of what platforms are able to perform without needing human intervention. This is mostly developing in the form of what Zacharias referred to as decision aid support, meaning machines will be able to better interpret, organize, analyze and communicate information to a much greater extent, without having humans manage each individual task. A person comes in and does command and control while having a drone execute functions. The resource allocation will be done by humans, Zacharias said. The early phases of this kind of technology is already operational in the F-35 cockpit through what is called sensor fusion. This allows the avionics technology and aircraft computer to simultaneously organize incoming information for a variety of different sensors, and display the data on a single integrated screen for the pilot. As a result, a pilot does not have the challenge of looking at multiple screens to view digital map displays, targeting information or sensory input, among other things. Another advantage of these technological advances is that one human may have an ability to control multiple drones and perform a command and control function, while drones execute various tasks such as sensor functions, targeting, weapons transport or electronic warfare activities. At the moment, multiple humans are often needed to control a single drone, and new algorithms increasing autonomy for drones could greatly change this ratio. Zacharias explained a potential future scenario wherein one human is able to control 10, or even 100, drones. Algorithms could progress to the point where a drone, such as a Predator or a Reaper, might be able to follow a fighter aircraft by itself, without needing its flight path navigated from human direction from the ground. Unlike ground robotics wherein autonomy algorithms have to contend with an ability to move quickly in relation to unanticipated developments and other moving objects, simple autonomous flight guidance from the air is much more manageable to accomplish. Since there are often fewer obstacles in the air compared with the ground, drones above the ground can be programmed more easily to fly towards certain predetermined locations, often called waypoints. At the same time, unanticipated movements, objects or combat circumstances can easily occur in the skies as well, Zacharias said. The hardest thing is ground robotics. I think that is really tough. I think the air basically is today effectively a solved problem. The question is what happens when you have to react more to your environment and a threat is coming after you, he said. As a result, scientists are now working on advancing autonomy to the point where a drone can, for example, be programmed to spoof a radar system, see where threats are and more quickly identify targets independently. We will get beyond simple guidance and control and will get into tactics and execution, Zacharias added. War games, exercises and simulations are one of the ways the Air Force is working to advance autonomous technologies. Right now we are using lots of bandwidth to send our real-time video. One of the things that we have is a smarter onboard processor. These systems can learn over time and be a force multiplier. There's plenty of opportunity to go beyond the code base of an original designer and work on a greater ability to sense your environment or sense what your teammate might be telling you as a human, he said. For example, with advances in computer technology, autonomy and artificial intelligence, drones will be able to stay above a certain area and identify identified relevant objects or targets at certain times, without needing a human operator, Zacharias added. This is particularly relevant because the exorbitant amount of ISR video feeds collected needs organizing algorithms and technology to help process and sift through the vast volumes of gathered footage, in order to pinpoint and communicate what is tactically relevant. With image processing and pattern recognition, you could just send a signal instead of using up all this bandwidth saying hey I just saw something 30 seconds ago. You might want to look at the video feed I am sending right now, he explained. The Army has advanced manned-unmanned teaming technology in its helicopter fleet, successfully engineering Apache and Kiowan air crews to control you as flight paths and sensor payloads from the air in the cockpit. Army officials say this technology has yielded successful combat results in Afghanistan. Senior Air Force leaders have said that the service's new next-generation bomber program, Long Range Strike Bomber or LRSB, will be engineered to fly manned and unmanned missions. Navy Secretary Ray Mabus has said that the service's carrier-launched F-35C will be the last manned fighter produced, given the progress of autonomy and algorithms allowing for rapid maneuvering. The Air Force, however, has not said something similar despite the service's obvious continued interest in further developing autonomy and unmanned flight. Also, in September of 2013, the Air Force and Boeing flew an unmanned F-16 Falcon at supersonic speeds for the first time at Tyndall Air Force Base, Florida. The unmanned fighter was able to launch, maneuver and return to base without a pilot. At the same time, despite the speed at which unmanned technology is progressing, many scientists and weapons developers are of the view that human pilots will still be needed, given the speed at which the human brain can quickly respond to unanticipated developments. There is often a 2-second long lag time before you as in the air can respond to or implement directions from a remote pilot in a ground station, a circumstance which underscores the need for manned pilots when it comes to fighter jets, Air Force officials said. Therefore, while cargo planes or bombers with less of a need to maneuver in the skies might be more easily able to embrace autonomous flight, fighter jets will still greatly benefit from human piloting, Air Force scientists have said. While computer processing speed and algorithms continue to evolve at an alarming pace, it still remains difficult to engineer a machine able to instantly respond to other moving objects or emerging circumstances, Air Force scientists have argued. However, sensor technology is progressing quickly to the point where fighter pilots will increasingly be able to identify threats at much greater distances, therefore remove the need to dogfight. As a result, There may be room for an unmanned fighter jet in the not-too-distant future, given the pace of improving autonomous technology.